Okay, in this lecture we're going to be going over estimation and confidence intervals for population proportions. So the very first thing that we probably need to do is find what is a population proportion. So we're going to be able to compute and interpret these proportions and the margin of errors. So what is a proportion? A proportion is essentially when you have a population and a percentage of the population has a particular quality and the other percent of the population does not have that particular quality. So a proportion is calculated by taking the number that has that quality, the number of observations in that population that has that quality, or the number of observations in a sample that has that quality, and dividing it by the total number in the sample. So x would be the number of successes or the number of observations in the sample that has that quality, and n would be the total number in the sample. For example, we have Southern Tech Career Services. They report that 80% of its graduates enter the job market in a position related to their field of study based on a survey of 100 graduates. So they surveyed 100 graduates, 80% had a job in their related field, while 20% did not have a job in their related field. This is not saying that 20% had a job, it just wasn't in their related field. It's also not saying that, it could be that they don't have a job at all. They're completely unemployed. There's a lot of things that this 20% could constitute, but with this proportion, we're only looking at success versus not success, or they have the quality versus not have the quality. Similarly, down here, so the proportion is, right here, the proportion is 80%, or 0.8. 0.8 is the proportion. A recent study of 200 married men between ages of 35 and 50 found that 63% felt that both partners should earn a living. So right down here, you've got the proportion. 63% is the proportion. 63% say both partners should earn a living, and 37% do not say that. Once again, that 37%, you might have 20% that say, oh, I really don't care. They can earn a living if they want to or not. And then another 17% says, oh, no, they shouldn't earn a living at all. Them earning a living is them staying at home and taking care of the home because that's what needs to be done. And so, it could mean lots of different things. That 37%, we don't know what that's comprised of, but all that we care about is the dichotomy of they believe that they should earn a living versus they do not. They have this quality versus they don't have this quality. That's all that we care about with the proportion. Okay. So a population proportion is identified by the pi symbol or by p. I use p for the most part, but you might see pi. When you see pi, it's not 3.14. It literally means proportion. So once again, like I said, there's two requirements. The binomial condition must have been met. So in other words, there's only two possible outcomes. So you've got one possible outcome, you've got another possible outcome. They have the quality versus they don't have the quality. They have the quality versus they don't have the quality. And so, let's see here. The binomial conditions are met. The value of n multiplied by pi and n multiplied by 1 minus pi, in other words, n multiplied by the proportion and n multiplied by 1 minus, or the inverse of the proportion, should be greater than or equal to 5. In other words, you don't want to have like a minuscule proportion with a small sample size. So if you have a proportion of, 98 and 2%, 98% and 2%, and your sample size is 10, well, that certainly is going to be really close, and that's going to literally land right on that line of 5 for the 2 multiplied by 5, or multiplied by 10. Well, actually, that wouldn't land on 5. That would land on 0.5. So you would need to have 80% and 20% with a sample of 10 in order for it to land on 5. So you shouldn't have a small sample with extreme proportions. If you're going to have extreme proportions, you need to have a much larger sample. So you would need to have a sample size of 100 if you had a 98 and 2%. So we, right here, we've got the formula for the margin of error. So this is going to be the z-score. Remember, the z-scores are going to be, 1.645, 1.96, 2.576. It's going to be, one of those based on 90, 95, or 99%. And so That's really important to note, that we are always dealing with z-score, and then you take the square root of the proportion multiplied by 1 minus the proportion divided by the number in the sample, and then you multiply that by z, so that gives you the margin of error. And then for the confidence interval, you essentially double the margin of error. So let's take a look at what that would look like. Once again, we've got these examples, which I've got these flipped around. Sorry about that. It just worked a lot better with the way that I had it situated. But let's look at Southern Tech Career. They have the 80%, remember, and the 20% not. So if we have the margin of error, we go through this entire formula, and then we put 80% multiplied by 1 minus 80%. So in other words, 80% multiplied by or 0.8 multiplied by 0.2 divided by 100, and then you take the square root of that. So let's take a look at this, at what this would look like. And so we would take equals 0.8 multiplied by 0.2, okay, and then we do equals this multiplied by 100, and then we take the equals square root of 0.0016, and then we multiply that by the z-score. So let's assume that we are going to do a z-score of 95, or sorry, rather, that we want to have a confidence interval of 95, or a confidence level of 95. So we're going to do equals 1.96 multiplied by 0.004, and so that gives us a margin of error. This right here is the margin of error of 0.0784. But the margin of error, so this is for a 95% confidence interval, the margin of error is going to be 7.84. 7.84, which is basically, hey, we know that it's 80% of the individuals got a job in their chosen field, but we might be off by about 7.84%. And so if we were to do a confidence interval, it would be, 80 minus 7.84, and then 80 plus 7.84. So it would be 72.16 and 87.84. But looking at the confidence interval right up here, so we've got a confidence interval with a recent survey of 200 married men, we've got 63% of both partners should earn a living, and so with a sample of 200, let's come right back in here. We have, I've got this fun little calculator. We've got a sample size of 200 with the proportion of, what was the proportion that we had? The proportion is 0.63. 0.63. And how confident do I want to be? I want to be 95% confident. And so what we're going to have is 0.56. So once again, I switched these around, and I accidentally did a sample of 100. So 56.309 or 31. And then we have the upper is going to be 69.6 or 0.69. 69.69, or we'll just do 69.7. So we've got 69.7, so the confidence interval is going to be between these two values right here. And if I were to change this to 100, like I said, it shows you what I had before there. I just accidentally switched those up. So, but the confidence interval is going to be essentially, I am 95% confident that the actual population proportion is going to be between 56% and 69.7%, 56.31% and 69.7%. So the actual population proportion will be in this confidence interval, and the margin of error is saying, hey, this is how much I might be off by a little bit. So this is the population proportion, and I might be off by about 7.84%. So moving on, we've got, here's an example. A recent publication indicated that 40% of college students have cheated on a written assignment. And if you watch my video that says, what are we even doing, you'll see what I'm talking about. There's this thing, there's this stats example that's a really poor example, but it says, oh, 40% of individuals have cheated on a written assignment. Me as a professor, I'm going to say, oh, you know what? I want to see, what about my students? So I'm going to do just as bad of a job taking bad statistics, a bad samples, so on and so forth. And so I'm going to take a survey to see if that proportion is representative of the students in QBA. So I randomly survey 17 students. 17 students. So 5 out of the 17 indicated that they have cheated on a written assignment in the past. Is it possible that the statistic of 40% may be accurate for the students in Professor Eide's QBA course, and with a 90, and I actually did a 95% level of confidence? What is the estimate of the population proportion? Okay, so the very first thing that we need to do is we need to calculate the proportion. We take the number of successes divided by the total number of possible, or the total number in the sample. So 5 divided by 17 gives us 29.41%. 29.41% of the students say, hey, I've cheated on a written assignment in the past. So that's our point estimate. The point estimate of the population proportion is 29.41%. And if you look right up here, this right here is, hey, we've got this population proportion right here, and this is the 40%. This blue line right here is the 40%. And so the next thing that we need to determine is we need to determine the margin of error with an alpha of 0.95. So right here, we've got the margin of error formula, and so we take the z-score, which is 1.96. So for 95% CI, or level of confidence, we're going to use 1.96. We're going to multiply it by the square root of the proportion multiplied by 1 minus the proportion divided by the total number in the sample. So once we work all of that out, that's going to give us a margin of error of 0.2166. And you can work that all out for yourself as well. There's no real Excel formula for this. It's just, working it out little by little until you get that margin of error. And then once you get the margin of error, then you're able to say, okay, we've got this margin of error. The margin of error is 21.667. In other words, I have that 29.4% of individuals in my class indicated that they've cheated from the sample that I took, but I might be off by as much as 21.66%. Okay, let me repeat that one more time. From the sample that I took, 29.14% indicated that they cheated sometime in the past. But I might be off by as much as 21.66%. That's huge. It means I really have no clue. Okay? So once I work that out, so I've got the margin of error right there. And I could put the margin of error on either side. It really doesn't matter. But that's the margin of error. That's just saying how much I might be off by. But once I take the confidence interval, technically the margin of error doesn't go on either side. It's the confidence interval that we put up here. But it's a confidence interval. The lower limit is 7.75%, while the upper limit is 51.07%. So what we're saying is that we are 95% confident that the actual population proportion is between 7.75% and 51.07%. In other words, like I said, we have absolutely no clue. 95% confident that it's in this range of 43%. Roughly 43%. And so, yeah, it's definitely possible that that 40% is, that 40% is in there. So how do we fix this? How do we make this better? Because obviously this is horrible. You can't publish this. You can't put this out there. This is just horrible statistics. So what should we do? Well, we can do a few things. The first thing that we can do, so this is what we just calculated right here, up at the very top, and the margin, or sorry, the 40 goes all the way down from the top to the bottom. So the first thing that we can do is we could possibly decrease the confidence, the alpha. We could decrease it from 95 to 90. This is a very bad idea. You don't want to take the opportunity to say, hey, by the way, I wasn't able to demonstrate this, and so therefore, since I wasn't able to demonstrate this, I'm just going to show you how confident I actually am. If it's not 95% confident, or if you go out and you say, hey, I want to know, is it 90% confident? And if it doesn't hit that, don't change it. Just say it wasn't 90% confident. You expected it to be 90% confident, and if it wasn't 90% confident, don't change it. Just note, hey, we were not able to demonstrate that we're 90% confident. So right here, we are not able to demonstrate that my sample of students are below that 40% threshold. Again, so this was the original 95 with 17. This is the original 90. This is the 90% confidence interval with the 17. So I decreased the confidence interval. And if you actually want to know how confident we really are, we're only 66% confident. 66% confident that the population proportion is below that 40. 66% confident, which if you look at the margin of error and you look at the confidence interval goes up to 39.96, right below that 40. So we are 66% confident that the actual population proportion will fall between these two values. But once again, don't ever do that. Don't decrease your confidence just to be able to say, we're not 95% confident, but we are 66% confident. Nobody wants to hear that. That's just poor statistics work. Better. This is what you should do. This is what you should do. You should increase the sample size. Okay? If I use that 95% confidence interval and I increase the sample size to 100 and it's still 29.4, then what I'm going to have is a margin of error. You look at the difference in the margin of error. Look at that. You increase the sample size, the margin of error is almost a third. It's a lot smaller. And then the confidence interval is also a lot smaller. And so we're able to say that we are 95% confident that the population proportion will fall between these two values. We are 95% confident that the actual population proportion will fall between these two values. And because the confidence interval is below that threshold of 40, we believe that the students in my class are below that threshold of 40. And so the other thing, so if we were to increase the sample size, which we increase the sample size right here, and we also increase the confidence interval, notice we are 95% confident with a sample of 100, but we're not 99% confident. 99% confident means that 99 out of 100 tries, 99 out of 100 random samples, it's going to fall between these two levels. Now, the 100th might be down here, might be up here. We don't know where it's going to be. Once again, 95th or 95% confident. That means that 95 out of 100 are going to fall between these two limits. But 5 out of 100 times it's going to fall outside of those limits. Whether it's going to be above or below, we don't know. And so the best thing to do if you have a confidence interval and you want to decrease the size of the confidence interval, one of the best things to do is to increase your sample size or to get a better sample. If you get a better sample, you might have a smaller standard deviation. There's a lot of things that, except with a proportion, you don't really have standard deviations. So just increase the sample size and it's going to make things a lot better. So that's basically confidence intervals around a proportion. Hopefully this was beneficial, and seeing this was beneficial, seeing that increasing sample size is the best thing to do if you want to decrease the size of the confidence interval. And also understanding that margin of error is the percent that we might be off. And that the confidence interval that we are 95% confident that the actual population mean will fall in here 95 out of 100 times when taking random samples. Cool. Look forward to seeing you guys in class.